Hello, welcome to the video. We are going to start section 8.1 today. We're jumping around a little bit in the textbook because what we're doing is we're working on transformations. So we did some transformations with just general graphs that we made up, and then we did transformations using our V-shaped graph, absolute value. What we're going to do next is transformations on our basic quadratic function. So the equation for the basic quadratic function is y equals x squared. Okay, and sometimes, of course, we'll write that as f of x equals x squared or g of x equals x squared. But here I just have it as y equals x squared. And what we're going to do is we're going to find out what this graph looks like. Since we've never graphed this one before, we're going to make a table. Now, you could just make a t-table with x's and y's. That would be totally fine. But since this is new to us and some of you like the big chart that I sometimes make, I'm going to make the big chart where I have room for my work. And then I also have a spot to write the ordered pair before I plot it. So let's go ahead and plug in some numbers. Let's start with 0. If I pick 0 for x, then I have y equals 0 squared. To square something means to multiply by itself. So 0 times 0 is still 0. So that means this graph is going to have a point at the origin. Okay, right at 0, 0. And let's go ahead and plug in 1 next. We could certainly plug in fractions like 1/2, 1/3, 2/3, but I don't think we want to do that. Let's just plug in the next integer. So 1 squared is 1. So we have the point 1, 1 on the graph. This sounds a little bit like the absolute value graph so far with 0, 0, and 1, 1. Let's see what happens when we plug in 2. When we plug in 2, 2 times 2 is going to be 4. So this is different than the absolute value graph, because for the V-shaped graph, it went 1, 1, 2, 2, 3, 3, 4, 4, and so on. So this is already differing from that graph. Okay, let's go ahead and plug in 3. 3 squared. So 3 squared is not 6. Be careful. 3 times 3 is 9. So 3, 9 is going to be on this graph. And I think you can start to see here that if you can do this without showing work, that's totally fine. Because I think a lot of you can picture plugging in 4. 4 squared is 16. So it's okay not to show the work. And if you try to plot 4, 16, you'll notice you don't have room on this graph paper. Okay, so just be aware of that. We're at a point now where the numbers don't fit anymore. And that's okay. So let's do this at this point. Let's move out to the left-hand side and let's start plugging in some negatives. So you guys probably still have space in your notebook, but in order to fit everything in the viewing window here, I'm going to go ahead and continue my chart with a -1 here. Okay. Now, if you can picture plugging that in, -1 squared is going to give you +1. If you want to show the work, you'll be squaring -1. So you do technically need those parentheses there, because what you want to be doing is -1 times itself. That's why it becomes positive, okay? Because when you square something, it means times it by itself. So -1 times -1 gives you +1, and that gives us another point to plot on the graph. Okay, let's see what happens when we plug in -2. When you go to square -2, you really need the parentheses exactly where I have them for correct work. All right, and when you square -2, that means you're doing -2 times itself. So -2 times itself is going to give you +4. So the next point on my graph that I'm going to plot is -2, 4. And again, if you start to get comfortable, I think a lot of you might be comfortable here, plugging in -3 without showing the work. If you square -3, so you're putting -3 here and squaring it, you're going to get a +9, because -3 times itself is +9. And I'm not going to bother going further than that, because we know from our work on the other side, when you plugged in 4, it was too big. It was 16. It was off the graph. If you plug in -4, you're going to get 16. It's too big. It's off the graph. So this is the beginning of our basic quadratic function. What I'm going to do now is connect the dots, and I don't want it to be pointy. Your basic quadratic function is a U-shaped curve or U-shaped graph, as opposed to a V-shaped graph that we've been working on the past few days. So I'm going to connect the dots, and I'm going to make sure that down at the bottom here, it's nice and curved. Okay, I don't want it to be a V-shaped graph. I want it to be a U-shaped graph. So taking a look, this is a U-shaped graph. Let's write that down. U-shaped graph called a parabola. That probably is a new word for you. So parabola is the special name for this type of U-shaped graph that you get when you graph y equals x squared, which is called a quadratic function. That's a lot of new words today. So the equation is this. It's a quadratic function, and the shape of the graph is a parabola when it's this U-shaped graph like that. The parabola here, it has a vertex. It has a vertex at 0, 0. We're used to a vertex being the pointy part of the graph. Okay, that's what we know so far about a vertex. But this is also called a vertex, even though it's a nice curve. All right. So just to expand your understanding of that word vertex, it's this point where the graph has a big change in the graph. So it goes from here, it's going down. We call this decreasing, and then here it changes to increasing. So this is a low point on the graph, and it's called a vertex. All right. And let's take a look at domain and range. The domain for this graph, since it has two arrows pointing the same way, it's going to go up forever to the left. It's super duper steep, but it's going to keep going up forever to the left, forever and ever and ever and ever, even though we can't fit the points, and same thing to the right. So like here, look at 5. If you were to plug 5 in, you get 25. So I do need this in the domain. It's just that it's so steep that I can't fit it. I mean, think about plugging in 9. If I plug in 9, I would have 81. So 9, if I plug in 9, I'm way, way, way up there. There's no way I can fit that on this graph paper. But the graph does go forever to the left and forever to the right. So it's all real numbers. I'm going to use that fancy symbol for all real numbers. The range, however, is not all real numbers because this vertex, like I said before, it's a low point. All right. So the lowest the graph goes is 0. The graph is always 0 or higher for your y values. So this is our basic quadratic function. Its shape is called a parabola. And what we're going to do starting on our next lesson is we're going to take this graph and do transformations. We're going to move it left and right, up and down. We're going to reflect it over the x-axis. When you reflect it over the x-axis, by the way, the vertex is no longer a low point. The vertex becomes the high point on the graph. If you can picture flipping this over the x-axis, you'll still have a vertex. That's where that graph makes a really big change. But it'll be a high point instead of a low point on the graph. So we'll be doing horizontal shifts, vertical shifts, reflection over the x-axis, as well as vertical stretches and shrinks in our next lesson. All right, thanks for watching.